All right, this lesson today is going to be about the group trends in the periodic table. So we've been talking about the periodic table and some of the trends that we can see in atomic mass, atomic number, metallic properties, all of those things. Well, it turns out that when they organized all these elements, that the groups, the vertical columns, each have specific properties that line up and are very similar. So we're going to talk about what some of those groups are and why they act similar and what are the properties of those different groups. We're going to start off with the group all the way over here on the left with hydrogen, lithium, sodium, potassium, and rubidium, cesium, and francium. All right, these are called our alkali metals. And we're going to look at a couple of different board diagrams. Here's lithium, one of the elements in that group. And how many valence electrons do you see that lithium has in this picture? Hopefully you said one. There's one electron in this outer shell here. Okay, here's another one from this group, sodium. And how many valence electrons does sodium have? If you look in this outer shell, it has one valence electron. Here's potassium, and as you guessed it, potassium has one valence electron. And we have rubidium, the biggest of the four, but still, even though it has all of these electrons, only one of them is in the valence shell. So the reason why the elements in this group act similarly is because all of them have one valence electron. And since it's those valence electrons that are working in a chemical reaction, these are all going to act similarly in a chemical reaction because they all have that one electron they're working with. It's just that rubidium is much bigger than lithium, but they each have one valence electron. Okay? So the alkali metals, this group here all the way on the left, we call them, they're also group 1, which is how we've referred to them in the past. They're very, very reactive, okay? Because they only have that one valence electron, it's easy for them to react and give that electron away. They're also going to have low density, excuse me, and they're going to be soft, and they're going to be usually silvery in color when you see them. So they'll look like a metal, or what you imagine a metal to look like. Okay, so make sure that you're writing down the properties in the group at the bottom of your page of your notes. You may need to pause the video as you move through it because I'm going to probably move faster than you can write. So once you get to a spot where you need to write, just pause it. Our next group that we're going to look at, here's a couple of them, beryllium. And if you look here, beryllium has 2 valence electrons. Okay, magnesium, the next one below beryllium, also has 2 valence electrons. Calcium, just below magnesium in the periodic table, has 2 valence electrons. So you can see, again, all the elements in group 2 have 2 valence electrons. Now, because they have the same number of valence electrons, they're going to act similarly as well. So this group here, group 2, we refer to them as our alkali-earth metals. Okay, these are also very reactive elements, but not quite as much as the alkali metals. Okay, and that's because they have 2 valence electrons instead of 1. Next group we're going to talk about is our transition metals, and this is a big group. Now these metals are much less reactive than our alkali or our alkali-earth metals. And they don't really like to follow rules. We've talked about that over and over. That's why we don't give them a group number. We don't know their valence number. But they do have similar properties, this whole big group of transition metals. So they're going to be really good conductors of electricity and heat. They're going to be very dense and have high melting points. So these are metals that we use a lot in building things and taking advantage of these properties. Okay? A lot of times they're also known as your heavy metals. This one's in the middle. Okay? Another group in the periodic table is the noble gases, and they're all the way over here on the right side. These elements already have a full shell of valence electrons. They have 8 valence electrons in their outer shell. Now, all atoms want to have a full outer shell. That is why they do chemical reactions, because they're trying to get a full outer shell. So these ones, your noble gases, helium, neon, argon, krypton, xenon, and radon, They already have a full outer shell. So they're saying, you know what? I don't need to react with anything. And that's exactly what they do. They're the most unreactive elements that exist. Since they already have that full outer shell of 8 valence electrons, group 8, they don't react with anything. And another group just to the left of those noble gases is our halogens. That's this yellow group here. The halogens are very reactive, almost as reactive as our alkali metals, the first ones that we talked about. They're nonmetals though instead of metals, and they'll have a lot of similar properties as the other nonmetals. Okay, so we've learned the nonmetal properties earlier this year, but they're very, very, very reactive, so that is an important thing to know. Hydrogen is a very unique atom. If you noticed in the picture, it had its own color. It wasn't part of any of the groups. And the reason why that is because hydrogen is the only atom that has only one proton and one electron, no neutrons. So it's kind of unique. Because of this, it doesn't really fit with anything else because nothing else has that ratio of parts. But it is very reactive, which is why you see it over on the same side as the alkali metals. It's also one of the most abundant elements in our universe because it's the lightest one. And they used to fill up blimps with hydrogen because hydrogen is less dense than air. So if you put hydrogen into a balloon or into a blimp, it will float, it will fly. The problem with that is that if it catches a spark at all, hydrogen is very reactive, so very explosive. And you would see things like this picture where the hydrogen somehow caught on fire and the entire blimp will explode then. So again, when you go over to Party City, they don't fill your balloons with hydrogen, they fill it with helium now because helium is also less dense than air but not quite as reactive as the hydrogen gas because helium is a noble gas and will not react with anything. So much safer to fill your balloons with helium than hydrogen. And that's it for these notes. If you have any questions, let us know.